Hi guys, I'm Karan Singh. I'm an architect at Red Hat and a developer evangelist, helping developers to try out new tools, try out the right tools for getting them up to speed with Kubernetes, Openshift, and all the open source technology that is being supported by Red Hat. What I do in my day-to-day job is kind of mentor and guide developers around productivity, how they can use these tools. I train them, I share some content with them which are useful for them, and that's what I do typically. And then part of my responsibility is to build design scalable distributed architectures on top of Kubernetes, and making sure that the software that you guys gonna deploy on it make total sense for you. So that's about me. I'm gonna share my screen and begin the conversation for today's talk around how we can leverage GitHub Actions on top of Kubernetes. And so I'm gonna share my screen. The agenda for the day is pretty packed up. We're going to talk about starting from Git, touching upon Git and GitHub and what is OpenShift and Kubernetes and the Agile and DevOps way of doing the software development, touching upon CI/CD, how the CI/CD pipelines are important, and then viewing it from 10,000 foot, or maybe I should say viewing from the space, all these different Agile, DevOps, CI/CD, GitOps, these kind of tools, and making sure that we understand it. Finally, then moving on to GitHub Actions, the topic of the day, and how we can deploy an app, actually two apps using GitHub Actions on top of Kubernetes. You will also know about events, and then what are the core concept of GitHub Actions, and we'll go deep dive into GitHub Actions workflow file, which will help you build your own file for your own architectures. And then touching upon two more demos, which will make things clear for you. So let's dive deep into it. All right, starting with Git and GitHub. So Git is one of the most popular version control software out there. It is open sourced and built in 2005. As a matter of fact, in 1991, Linus Torvalds developed Linux kernel. Linux is one of the most popular distribution, and in 2005, they feel that there's been a lot of problem while getting and managing code bases from thousands of developers across the world who are doing the commits on Linux kernel. So they have to find a smart way to manage their code bases, distributed code bases. So Mr. Linus Torvalds built another open source software called as Git in 2005. Since then, people are using Git, and it's the most popular version control system. Then in the timeline series in 2008, GitHub came up, and they packaged Git as a hosted service on top of cloud. This is how GitHub born in 2008, and following the path, GitLab packed the same Git open source software into their own SaaS and cloud-based environment that we know as GitLab. So this is just to give you an idea like how Git and GitHub and others evolved over time. Switching gears here, you're all developers, I assume, and how does it looks like to you? How the big picture looks to you? So I'm pretty sure you would be good in writing some code in your popular languages, Go, C++, Python, Java, whatever it is. And you know that all of these languages have some kinds of dependencies in packages that you need to install while building or making sure that your app functions, right? Source code plus dependencies, and then you have to deploy, or you have to you have to deploy your app, and your app also needs some kind of binaries and libraries and runtimes so that your code could actually execute on any machine. So this is the yellow box in here, which is the binaries and libraries. Docker came up, or I should not say Docker, the container revolution came up like long back, close to from the old days of the Unix and jails, file systems, and Solaris. I'm forgetting the name of that technology, but the zones, Solaris zones, and then moved on. So this entire thing came up, containers came up, and then Docker came up pretty fast in 2012 and 11ish time frame. They built a nice packaging around what's the best way for the developer to package their code and ship it, which we also known as containers. So a container contains your source code, it contains the dependencies, it contains the necessary binaries and libraries, which makes it easier to port to any machine. any system. A combination of these containers are typically known as microservices. There could be one, there could be many, there could be thousands of microservices in any architecture, depending on the complexities. And these microservices then expands to solve bigger problems and bigger use cases. And they look like the Death Star that is shown below for the known as Amazon.com Death Star. It's a data from Amazon in 2018. So this is how their various microservices look like. They're like thousands of microservices interacting with each other. And then same goes for Netflix. They have thousands of microservices which interact with each other. Why all of this? Because you got to know Kubernetes. How you can manage these thousands of microservices in a cloud native way. You have to have a way or a software or a smart software in place who can manage thousands of containers that are running in the system. So that's how Kubernetes came up back in 2014 or 15ish timeframe, built by Google, open source by Google, and then Red Hat, IBM, and a lot of other companies joined the bandwagon of Kubernetes. And Kubernetes is like right now the most popular container orchestration and management system out there. So that's how, right from source code until Kubernetes, this is how a very high level journey looks like for a developer. So what is Kubernetes? I touched upon this previously. Kubernetes is an open source orchestration software for deploying and managing containers at scale. Scale is like Amazon or Netflix. You don't need to be an Amazon or Netflix to use Kubernetes. It's just a representation. I'm showing you what Kubernetes could do. And it does not also mean that Amazon.com runs everything on Kubernetes or Netflix runs everything on Kubernetes. It's just a representation. I'm giving you how different microservices and how Kubernetes is equally the way to deploy thousands of microservices. And then there come Openshift. So Openshift is Kubernetes. So Openshift is an enterprise-ready Kubernetes container platform, which provides, a consistent application platform across on-premise and multiple cloud environments. As you guys know, there are lots of public cloud providers: Google, Azure, Microsoft, and DigitalOcean. And then you also have your own servers living around your own data center, right? You have to got a seamless way so that you could go multi-cloud in your infrastructure journey. So OpenShift and Kubernetes makes it possible. So the whole idea of OpenShift and Kubernetes is that there would be a single plane on which you could deploy your application irrespective of the underlying hardware or underlying cloud provider. So that's how OpenShift and Kubernetes are used. Okay, switching gears, let's talk about Agile and DevOps. What is Agile? What is DevOps? And what is CI/CD? Right. So Agile is a framework. It's kind of a way. It's kind of a principles, a set of rules, a set of principles that people use to build great softwares. Great companies used to build great softwares, right? And DevOps is a sub form, I would say, of Agile, which basically leverages all the principle of Agile and helps development team and operations teams to come closer and build release frequent software, high quality software. And then CI/CD. CI stands for continuous integration and CD stands for continuous delivery or deployment. It's a DevOps tactics. Like, okay, great about theoretical knowledge. Let's do something practical. So it's from CI/CD part, practical things comes into picture. You will deploy a code. Actually, let's go to the next slide. So this is how a CI/CD pipeline look like. So you're a developer. You will start writing your code in version control system, which is Git. Once your code is done, you have to, depending on the runtime, but yeah, you typically have to build your code. Which will then you will run some unit tests. So the first three parts are a part of continuous integration. And then as you move on, you need to deploy your code to either test or dev or production environment. You need to do some automated testings in the system, and then you need to measure and validate, okay, how the system is working. And you have to have a way that a continuous feedback is provided to the developer and the actual team supporting it. So the second part is called continuous deployment. So this is how CI/CD works in conjunction for any software development release. Okay, so let's now also throw one more popular keyword that is very popular right now. It's GitOps. What the heck is GitOps, right? So GitOps basically uses one part of DevOps. which is the CI part, the continuous integration part. GitOps uses its own way of deploying things. That's the reason you can see the circle does not span across CD, because GitOps use CI from DevOps, its counterpart, and have its own continuous deployment mechanism. And very specifically, GitOps, one will do GitOps on Kubernetes environment. At least for now, that's how people are doing it at the moment. So since it says GitOps, Git is the main version control system. There's a tool called as Argo CD, again another CNCF provided open source tool, which runs on Kubernetes and which will continuously monitor your Git repository. And as soon as there is a new change in your Git repository, the change would be captured by Argo CD, and then it would be deployed onto a Kubernetes cluster. So that's how, you as a developer, you just need to push your code to Git and just leave it. Argo CD will pick it out and deploy that onto Kubernetes. So that's how very superficially the GitOps looks like. Yeah, that's my way of explaining these things from the space. We are not going very deep into this at the moment, but I hope you can get an idea. Switching gears once more. Think about what should we do with GitHub and GitOps and Git and GitHub Actions. So GitHub has came up with a concept called as GitHub Actions, which, as the name suggests, these are actions, these are events that you do on a Git repository, and GitHub will capture those events and allow you to do your favorite step that you want to execute next, right? I'm going to go into this detail. And GitOps, on the other way, it continuously monitors your Git repository. It could be any Git repository. It could be a standard Git repository from Bitbucket or GitLab or GitHub. However, GitHub Actions is very specific to GitHub. You could not run a GitHub Actions on a GitLab repository because it does not support it. For the talk today, we're going to focus on GitHub Actions. So as soon as there is a new change or there's a new event occurred on GitHub, there would be an associated action which will get executed. Let's say in this case, okay, the action is deploy a container, build a container out of the code and deploy that container to Kubernetes. That's one action. You could choose your own favorite action if you want to. Yeah, I just touched upon this. Skipping the slide. Okay, so let's go 1,000 meter deep into this. As a developer, you would do git push, and git push is an action on GitHub Actions. So as create a PR, merge a PR, create a tag, and those kind of stuff. Obviously create release also. So as soon as these events happen on a Git repository, GitHub Actions will sense it, and they will take necessary actions that we have instructed it to do. Okay. So what all things we could do with GitHub Actions? So actually you could do a lot of things, which means it could give you a lot of different ways to automate your environment. So for example, okay, project, create a card. There's a feature in GitHub called as you can create cards and tasks. Pull request, review request, push request, doing releases, deployment, issues, labels. So all these are actions on GitHub, and as soon as the action gets triggered, you could get your job done. Here's a list from GitHub. Okay, good. So how about what's one thing about the core concept? So action and task is the core concept in GitHub Actions, which are then used in steps, and steps forms jobs, and jobs forms workflow, and workflows are run or executed on a runner. A runner could be a GitHub provided runner, or you could also use your own runner if you like to. So this is how the hierarchy looks like. GitHub Action is if this then that for GitHub repositories. So if this happens, please do this job. So it's pretty simple to understand. Okay, so this is the actual GitHub workflow file that I've created for the example. So on top you will write okay, go back. Yeah, on top you will tell, okay, this is the event trigger on a PR. This is how your event get triggered. You will set some environment variables or secrets which are required for your application to be deployed on the destination platform. And Docker username, password, pull secrets, or Openshift or Kubernetes URLs. So those are secrets that you don't want to expose. So you'll create a secret and use it here. Then you will create some action. You will use some actions. So there are a lot of pre-created actions out there in the marketplace. You could choose to use it. I'm using one action, which is check out the branch. And once the code is checked out, I will get the SHA of it because I want to label my image. And then we'll write some shell commands. Okay, Docker build, Docker login, Docker push, those are standard commands that you will build your container image. And then finally you will you'll take another action, which is called as Red Hat Actions /OC login, which is a Red Hat provided action, again open source on the marketplace, which help you to log in seamlessly to an Openshift environment. So you'll provide those environment variables, and then you will just deploy your app in a single command. So whenever an event occurs, this is the process that GitHub Action is going to take for us. Moving on next, let's go to demo. Step one would be, okay, a developer will do a git push, standard. He will do a git push to the remote branch, and a developer, let's say I'm a junior developer, I'll do a git push, and then I will create a pull request onto the main branch. The PR will go to my GitHub. As soon as the PR goes, there's a GitHub action which will get executed, which will deploy my code onto Openshift, right? And then my senior developer, my colleague, came up, hey, okay, Karan, I'll review your request, and he will do a review, and then he will say, okay, this looks legitimate to me, let me merge this. So he will merge my PR into the main branch. Again, there is another action which will trigger another build, deploy my code to production. And then finally, after a week or so, my team, when they are ready for releasing the software, they will create a new tag on GitHub, and then they will create a new release 1.0, whatever. So these also will trigger 2 more actions, and accordingly, GitHub Actions will deploy it to one or many OpenShift or Kubernetes clusters. Dev, test, or prod. So this is how the system will look like. And let's go to the demo part of our presentation here. I'm going to show you I'm going to show you 2 apps. So this is one app that I've been working on. So this is how a Docker file looks like. This is a Docker file. I'm going to explain you that in a moment. Just bear with me for a minute. So you're a developer, great. You have let's do a change, right? Let's do a change. I'm doing the most expensive change, echo readme. Add a new line to readme. Okay, so it's a new change in my local code base. What I'm going to do next is, my steps are, okay, git commit, git push, okay, commit, git commit, git add to add the file to the source control, git commit, okay, fixes from git commit commit show, okay, and I'll do a git push to my dev branch, okay, so my code is now getting pushed to GitHub repository. Okay, my code is now pushed. Let's go to GitHub Actions. We'll see GitHub. We'll go to my dev branch, Karan development branch. Okay. Oh no, we are in the wrong repository here. Okay, we'll go here. Karan dev branch. There is a new commit, and I'll do open pull request. Again, I'm a junior developer. I'm doing a PR. There's a single line change in here, and create pull request. So as soon as I create a pull request, GitHub action will get automatically triggered, which will build my entire code base, pack it into container, install all the dependencies, launch my container or push my container to the container registry, and then it will also deploy my container onto Openshift. So this is the level of automation a developer can get using GitHub Actions. So that's the whole idea about this talk. Like, okay, please save your time, and by not doing this manually, GitHub was very generous. They provide a lot of cycles for GitHub Actions free of cost. So if you're running a public repository and playing with containers and deploying it on containers, you should literally go and check it out. And so if you see this step by step, it's doing login, checkout, and building the container image for me, and then Docker login, pushing the image to the Docker hub. Actually query.io in my case, which is also a container registry, and then deploying it, and then doing authentication against my OpenShift cluster. And yeah, looks like this is done. So I'll go back to my pull request, and I'll see, okay, and I've also added a GitHub Actions bot, automated bot, which will upon successful deployment of my app, the bot will send you a message, hey, congratulations, your app is available on this endpoint. So if I go and click on this, it will show my racing game app, which the organizer can ping you on this call. So, okay. It's loading up. By the way, this is all running on Openshift at the moment. So this is a racing app we just deployed using two commands, GitHub Commit and GitHub Push. So this is how, this is all running on Openshift and powered by GitHub Action, automation powered by GitHub Action, right? So I'm gonna not play this game. Maybe I'll play this, resume this after this call, after this presentation. Let's go back and by the way, organizers, if you have the link ready with you, please give it to the users and the audience here to play around after this talk. I still have a lot of good things to show you guys. Okay, coming back here to our VS Code terminal. So that's one app. Let's go slightly deeper in and understand more about this. So I'll open my GitHub file. Okay, so this is, as I showed you, this is the actual GitHub deployment file, which looks like this. On pull request from the main branch, these are the Docker variables I'm gonna use, and this is how you're gonna build an image, deploy an image, right? And so let's do it one more time, this time slightly more in more detail. So for all the Python developers out there, I have a basic Python fast API backend. Okay, hello world is the current output message. I want to say hello, hello git commit. What's up? Okay, so I did a change locally on a Python source code that I have in my system, and then I want GitHub to automatically build a container image out of it. So I'm going to use a base image, rel UBI image, install Python, copy the requirements file, install the requirements, and expose my container on port 8080, right? Because in here, by default, this fast API is exposing this on 8080. So these are two main things that we have on our local code base. So I'll do commit again because I did the changes. Fixes on the development branch. Okay, DEVELOPMENT. Okay, I'm doing a git commit on the development branch. So this will push my code to my action files here. Sorry, to my development branch in my case. Again, I'll go open a PR. Bear with me. This looks similar to what I showed you last time, but I'm going to show you some more things in this one. So I'll create a pull request. As per the process that I set up, it will go and launch and GitHub action against it. So I'll not go into this right now. Let's go and see another GitHub action. The second step was, okay, once the PR is merged into the main branch, what should we do? Okay, so this is again the event. Okay, if my senior developer has done the push or the merge request, PR merge on my branch, please go and deploy this environment. This to maybe to a dev environment this time. Okay, we can, using these variables, we can segregate and we can select on which cluster you want to deploy this, or even on which OpenShift cluster running on which public cloud you can deploy this. So these are all environment variables fully configured for you that you could do. And this is how the exact same code. And then on the third stage, which is if I create a new tag, please do this event again. Do this on environment. Development environment. I can do a prod, but I don't have another cluster lying around. That's why I'm just using a same cluster. And then in case of a release is created. And from OpenShift and Kubernetes point of view, it looks like this. So this is an OpenShift cluster that you can grab by from reddit.dev.com. Get your own developer sandbox free of cost. Team will share you some more details after this call. So this is how a new container, a new pod will appear on the dashboard that you can see. And let's go back here. Okay, so my code is deployed by GitHub Actions. Let's see the output message. Okay, we are getting the right message. Hello Git commit audience, what's up? Fantastic. So all looks good. And my colleague will merge this code again to the branch. It will trigger one more build, one more GitHub action automatically. And if I go to actions, we'll see a merge, another GitHub action being triggered here. Again, it will do the same thing, but yeah, the idea is that typically in organizations, you will have multiple OpenShift and Kubernetes environment, dev, test, prod. First of all, you will deploy on dev, then move it to production or to prod, QA and test, and to the production, right? So that's why practically you would need lots of or a few handful of workflow files to make sure you're shipping your software onto multiple places where people can test it out before this goes out, right? So just bear with me 2 more minutes and we are done with the demo, and we'll open for questions. I just want to show you how the things looks like after this. This is almost done. Okay, post commit check. And at this point, the job is done. I'll go to my pull request here. And since I have automated, I'll go and see my request is completed. And we'll see now 2 messages from GitBot, GitHub bot, action bots. Like, okay, this is the endpoint, this is the endpoint, right? Again, if I go and see this, exactly the same thing, nothing will change in here, right? Okay, come back here on the code base. And now we are ready to release, correct? Let's go to tags and create a new tag from here. Okay, I think I'm missing the UI where you need to create maybe you know what, let's go to CLI. Yeah, UI is crazy sometimes. Tag. Okay, let's do it from here. Good. We'll tag from CLI. I have to figure out how to do this on GUI. I don't know. And do a git push origin v5. I think that should do it. Yeah, looks good. So we create a new tag. Okay, good. The tag is in here and version 0.5 is in here, and we'll see our action getting triggered again because we instructed it to do. And meanwhile, this is being in progress. Let me do and create a new release. Tag create release. And okay, launching this from space. Anyways, publish release. So we just released our congratulations, our new release 5.0 is out. And if I see in actions, it will trigger another action to deploy our code base onto our decided or the cluster on which we wanted to get this deployed. So this is how an overall workflow looks like. I'm right on time. I'll open up for questions now. And I have a takeaway for myself, like how to create a Git tag from GitHub GUI. I need to learn that. Okay, so so Pradeep, Sneha, and the team, are there any questions in the chat that I can answer?
Like, we would like to know more about Kubernetes part. What is it? How does it work? Or how do we get started with it?
Yeah, so that's a big topic that we cannot go over. However, I would recommend you to check out the Kubernetes official documentation. It's a fantastic place to start with. They have a lot of great content, and if you want to play around on Kubernetes, go to developers.redhat.com. In there, you will find a lot of resources, free resources for developers, where you can go and create a free account and launch a cluster. It would be kind of your own cluster that will stay with you. So enjoy deploying apps like I'm doing. I use a lot Developer Sandbox. It helps you test out and experiment practically your Kubernetes skills. So that would be 2 things I can give right now to the audience here.
Okay, and you also shared that there is an alternative to GitHub Action, which is Argo. When choosing which one to choose, how should people go about choosing out of GitHub Action or Argo, or if there is anything else?
Yeah, that's a good question, Pradeep. Actually, so what I've seen, I mean, I speak to a lot of Fortune 500 customers in my current role. So people who are using OpenShift and Kubernetes in production, they tend to use Argo CD, or maybe. Argo is by default the most important GitOps tool out there. So they use it because it comes with flexibility. You're not relied, or you don't need to use GitHub for it. If you're using Argo CD, is kind of you can do this GitOps across different Git providers: GitLab, GitHub, Bitbucket, Atlassian, even other Git providers as well. So that gives the flexibility to them. So, and people who are very tied to or people who enjoy working in the GitHub ecosystem, who don't want to manage their own kind of a controller, or don't want to deploy their own Git Argo CD instance or a controller, they choose to go with GitHub Actions. So it's more kind of a managed service for you versus Argo CD. You need to first deploy it and then use it.
Is the best to go
depending on your end goal. What is, and if you're in an organization where you're starting up with cloud native tools, and your organization level, you guys have decided okay, you want to use completely open source solutions, cloud native solutions, then I would say Argo CD would be the way to go for this. If you want to kick the tires and hit the ground, GitHub Actions, like I'm doing right now, right? So for your personal learning and for your fun projects, go and use GitHub Actions. You can go to my GitHub account and copy those YAML files and put it in your code base and basically do some changes out there, and you are good to go.
Makes sense. This transitions to segue to another point that I would like to discuss is over-engineering. Let's say I'm starting a side project, very simple project, and I decided, okay, I'll use Kubernetes, GitHub Action and everything. And the one-day project becomes 1 month project. So that we have such tendency as well. So what is the right choice to make? I mean, when do we start thinking about these solutions that, okay, this is the time? For now, I'll tell you my perspective. So right now I run multiple servers and I don't use Kubernetes and all. And what I use is simple bash scripts. So that automates stuff for me. So like people who are not using anything to automate their workflow versus people using some kind of, you can say, ad hoc solution to automate their workflow, versus finally you can say this is the top level of automating your workflow. So how do people move forward on these different stages? How to make the choices?
Again, one more good question, Pradeep. So what I've seen is, and honestly, writing bash scripts, they're good. They just work, right? So why do reinvent the wheel? However, if you firmly believe that what you're developing and deploying for yourself, for your company, for your startup, for any organization, right? If you firmly believe that you would need scale at some point, then you should be planning for it. And planning scale, which means you need to automate stuff. Scaling could not come without automation, right? So that's the gist in here. Scaling also does not mean deploy everything on Kubernetes. It's Kubernetes is just one way to do it. However, automation has to be in place to attain scaling. And honestly, yeah, tools like this, GitOps and Argo CD and Tecton pipelines and Kubernetes allows you to manage these things. Kubernetes, when I say scaling, okay, think about you have written a great code. You have a fantastic idea of, let's say, a new fintech startup in the world. You have started writing code and the code works fine on your machine. You have spent like 6 months building the product locally on your box. Correct? Now it's the time to launch it, and you are pretty positive that, okay, this is the next NFT revolution which will bring in, correct? And you will see hundreds and thousands of users gonna hit your URL and your APIs. So you need to start preparing for it, which means, the step one would be go and containerized. If you containerize that, make containers out of it, fantastic. That's level 1 of automation. Okay, good. You have containers, but how would you manage containers at scale? How would you manage, let's say 15 containers who is serving your backend APIs? And at load, that will go to 150 containers. How will you manage this? So that's wherein Kubernetes comes into picture. Okay, deploy, let Kubernetes manage this. So it is complex. It's not very easy. I'll not say, it is very easy to do it, but that's one way to do it. Another way is to use serverless architectures where, you just deploy things and let serverless manage for you. Knative is a great project which is working in the upstream community, and serverless, as in traffic comes, your scale, you'll attain the scale. If there is no traffic, your pods will go down, right? So yeah, think about scaling. If you believe that, or if it's your own personal project, you can choose to have on your own shell scripts or Ansible scripts, but At the same time, if you want to upspeed your career and make sure that you're using the right technology or technology that people are demanding for, right? Or making sure you are ready for the future. If you're a student listening to this, or I'm pretty sure you would be a great coder, but it would be beneficial for you if you learn these technology like containers and how to pack this and how to deploy this. So this is a good skill to have at the moment, because the line between dev and ops is already diminished. It's all one thing right now. Okay, a developer knows a lot of things about operations team, and an ops guy knows a lot of things about dev team. So there is no kind of a very clear distinction, and things will change, as in things like GitOps will come and it'll go mainstream. So that would be my 2 cents on this.
Got it. So basically, if I have to summarize that, if you are looking at scale, if you are deciding to use such solution, such automation, then GitHub Actions and Kubernetes combination, then you should be thinking at that point of time scaling your system. If that is your demand of the project, you're going to scale to hundreds of thousands of users, then you should start thinking about using such solution. But if you are, let's say, running personal projects or smaller projects which you don't have yet any plan to scale, then you are okay with starting with the scripts and then moving on to, if it is scales, then moving on to containers, creating a Docker image of it, or and using any container system. And then maybe when you have more requirement of scaling, then you start thinking about Kubernetes as well.
Right.
Am I speaking right?
Yeah. You summarized it pretty well, Pradeep. And just one thing to throw in here is don't afraid about Kubernetes, because Kubernetes is now pretty mature, and there are a lot of providers who gives Kubernetes as a managed service, and Red Hat is one of them, one of the popular. I know. There are a lot of other good providers as well. So you just need to order a Kubernetes cluster from the managed service provider, and they will give you a cluster up and running. You don't need to manage it. You don't need to run it. Like launch a cluster, like as you launch an instance on any cloud environment. You've got to play around with the terminology of Openshift or Kubernetes. Like, okay, what is a deployment? What is a pod? What is a service? What is a route? You just need to know, the fundamental of that. That's it. When you are good into it, it's just all about YAMLs. It's pretty straightforward from that point of view. If you're a developer, I would say, don't go and spend your time in learn how to know the etcd database of Kubernetes. You don't need to know that. Rather focus on your code. At the same time, just learn how to deploy an app on Kubernetes. That will solve, your 90% of the problems.
That's a great talk. We got to see how to use GitHub Actions and Kubernetes to automate the development workflow. We saw firsthand how it feels like to have such system in place.